All right, good morning, good afternoon, good evening, wherever this video finds you. Today is my favorite kind of day where we get to just write code and have some fun. Now, the example code that I give you may or may not be something that's assigned to you, but this is going to give you a little bit of a glimpse on how to actually complete it. One thing I do want to note is we're going to be using some code from your exception handling chapter. I do want to point out that I'm going to be looking for whenever you do numerical value inputs. Now this is a numerical value input example. Now notice that they're using a try when they attempt to do a conversion on an input here. So this is hours equals int input. So when you use a try catch block with your input and somebody inputs an alphanumeric character, it'll throw an error that you can catch down here that you can say, hey, we need to input numbers. Now guys, the reason why this is a requirement is because input validation is extremely important, especially when you get out and you're working with websites and JavaScript and whatnot. Somebody can literally type in code into a form input, like those forums that you post things to. You could actually put JavaScript in there instead, and it'll go post into the forum, and when somebody opens up that page, the code will actually run. So that's called code injection. So this is kind of a cyber security secure programming must. You have to validate your input. And so I'm going to require at the very least that you validate your numerical value inputs. So make sure you review program 6-23 of your book, or any kind of try-catch example that you can find that validates Python numerical value inputs. That's going to be something that I'm going to require you to do on your assignments. So we're going to actually do that, but for the example that we're going to be using today, we're going to be using the same code that we did in a previous value to open up a file and start reading from it. And the example that we are going to actually complete today, or not complete, I'm going to go to a certain point in the program and then leave it up to you to complete on your own. Would be the population data program. And in that program, we need to read a list of file contents and calculate the average population, the year with the greatest increase in population, and the year with the smallest increase in population. Now, I haven't actually done this particular one, and I haven't looked at the solution either. So there may be some Google searches along the way, and there may be some breaks that I take to fix some errors. I'm going to try to, I will, whenever I come upon an error that I create, I will give you information on how I got beyond and fix that error. But yeah, expect a few pauses as we progress in having some fun today on this particular problem. But let's first begin with the file itself and creating a program. So I'm going to go ahead. I went and I embedded that in here. You can find it in the source code files of your book. Even if you're given another assignment that you may have in here when I change this assignment, which I do often, you will have the ability to get that information. I'll probably embed it again with the changed assignment, and then of course you can go to your book or your book's source code and get that information. So this is just a simple text file that refers to the population. Now you see that it refers to something about years, and it means that this population data is years 1950 through 1990, but we don't see years here at all. Okay, well then how do I solve this problem, Mr. B? We don't even have, we just got a list of the population, but we don't have a list of the years of the population data itself. Well, we're going to infer in our loop that we start at 1950 and go through 1990 with each line of data. We'll get to that when we get deeper into the code. But let's, my main concern here is first, let's just start reading data from the file and printing it. I mean, seriously, that's what you, and again, you don't start building a whole program until you get your first parts. And that's, get your data, print your data. It's really that simple. You can't do anything with the data. You can't process it until you have it in your hands. So let's begin with getting our data and printing our data. That's where everything starts. And then from there, your program just blooms and completes itself. And sometimes even you get to use copy paste diligently, and all of a sudden it's done. So let's begin with that first step. Now I'm going to go ahead and get this file, download it, and I'm going to throw it on the desktop for now, because we're going to actually create a folder that is going to contain that. So we're going to create a new folder for our program on the desktop. I'm going to call it Chapter 7 US POP. Okay, and then the first thing we're going to do is, because I want to open the file implicitly without giving it a file location, I'm going to put, and I just drag population text file into that folder. So now what I'm going to do is I'm going to go ahead and I can create a PY file here, but you know what? Let's just do that in the editor. So we're going to start at Visual Studio Code, and I'm going to go ahead and blank out all the stuff that I got in here that we did and some other stuff that we got. And what could be nice is if we just open a folder and do things that way. So I'm just going to open a folder, and it kind of becomes like a workspace. And I can even work with the text file and kind of view it all in the same editor. So let's go ahead and do that. Let's open up the whole folder, Chapter 7 US POP. Okay, I've opened a folder, and you see it kind of changes. And we're going to say trust this folder. And now what I'm going to do is I'm going to go, and I can right click here and say new file. I can do new file here. I can go file, new file. I'm just going to right click here and say new file. And notice it pops up there what I want. And I can just say US pop main.py. And it knows that it's a PY file, so it's going to start all the PY file extensions that I have in here to work. Now what we can do is we can just straight up rip some code off of the book and then go from there. So let's go back to that code from the book. We need to be kind of careful and strip it out and make sure that we're not getting any weird characters. Now I have a little trick for this to not get weird characters. It looks like we're going to get new lines in there too, or some other stuff, but we might have to edit that a little bit. So I'm going to go ahead and do copy. Now the little trick I'm going to do is I'm going to throw out Notepad, because Notepad, what it has is the ability to, okay, so we got a few cleanup measures that, okay. Notepad has the ability to strip out any unwanted characters. So I usually just go ahead and grab the code, and I just get rid of all the white space, guys. I'm going to put it in my tabs generically. I'm just going to go ahead and get rid of all this stuff and tab it all in naturally. It looks like I didn't get rid of all the white space there. Oops. Control Z is your best friend, because it undoes without having to go and grab the mouse and do a big old undo. Get rid of all that white space. We may need to get rid of trailing white space, but we can do that when we do the tabs. So I'm just going to go in here and grab this code that I ripped off from your book, or from the book, or a book, which is you know, maybe I might have assigned a different book in another course, but so let's see here. We got now all the white space done with. And now we can take this stripped code and let's take it and throw it into our Python Visual Studio. I'm going to throw it in there. Now I'm going to deal with our tabs in. So we want this one, main needs to be tabbed in. Here, the main call with the if declaration that declares that we have a main. Then we have our main function actually defined up here. Let's throw some white space up here. But these all should be tabbed in. The comments not so much, but this should be tabbed in. And that only tabs it into the main scope. So that means, oh, it's part of main. Now we're going to tab it in and we say, oh, now it's part of the try scope. Now what I mean is scope is the local variables are declared within that scope. Other languages use these weird curly braces, but Python is old school and rather obstinate, and it also makes it harder to learn because scope is such an important understanding in programming, but literally it's invisible in Python as tabs. So you don't understand where things belong in your code in any other way other than to tab it in. So that means that this code belongs in this try block. And this try block ends at the end of all the things that are tabbed in with it here. Now this is the addition to the except block, and of course these need to be part of the except block, so they're tabbed in as well. All right, so now what we're going to do is we're going to hard code this, so we don't need that. We're going to go here and put our file name in. Now let's go ahead and be a little cheeky. And you know me, there's only one person that works against you, and that's yourself. So develop those little aspects. I know that I'm probably going to mess up on the name of the file and forget what I called it. So I'm just going to go in and copy the name out and just throw it in, literally. So I don't have to remember how I spelled it or what I called it or whatnot. It just doesn't matter. I'm just going to go grab it and then add the txt. All right, so now what we're going to do is it looks like this reads all the contents of the file. And right here, let's say the file, let's go ahead and throw in an error here, US population. You know what? This is kind of stupid. Let's not do things this way. Let's do this way. File name equals US population. And I don't believe case matters here, if I remember right. It shouldn't matter. So I'm going to put in the file name here. That way we can just refer to the file name, and if we change the name, it'll just be changed, and that way that stays the same. All right, so let's just make sure that we can read the file first, and then let's figure out, well, what are we gonna do with it? It looks like we've got a few errors here, and I think that's a copy-paste error there, guys. I think that there's spaces there that shouldn't be there. And that's very common when you copy and paste things from the internet. And that's why I don't recommend doing it and or using, you know, like the notepad to try to strip some of it out. And a lot of you would just be stuck at this point when you don't realize that, hey, that's a formatting error. So you may want to stick with just typing it out, but it looks like that error popped up for us and I was able to identify it. So it had spaces in here and we needed to take those spaces out. Okay, now we've got an example. Let's see if we're even just reading this file before we begin any further. And okay, so we are reading the file. Great. Now, from the description of the program, it stated that we need to do some mechanics on it line by line. So that means that we need to kind of tokenize this and also have some variables along the way that describes what year of the U.S. population that we're actually reading in. So we may want to actually create a list that has the year and value pair. That would be a dictionary. That's our next chapter. Excuse me. We're going to just do a list that represents the years from 1950, I believe. We will start the list. Let's do this. Let's go back to the actual assignment. Mid-year population of the United States in thousands during the years 1950 through 1990. So we know the first line starts with 1950. And it goes for so forth. So we know every year that it contains. So we know that we can just create a year value and count it up, and we will have an understanding of it. So what we could do is we can know that if we do put this in a list, we can know that the year 1950 starts at location index 0 value. So let's go ahead and do that. Let me see. Let's go ahead and go back to the code. We're going to need a year variable. And we're going to start the year at 1950. And what we're going to do is we're no longer going to use this read all file. What we're going to do is we're going to grab each line at a time using our for loop. And let's do the for line in example. So let's do a for line in file. So for every line in the file, we're going to read that line. Now let's look at it in the debugger because we may need to strip out. Now you notice I tabbed it in to put this in the scope of the for loop. We're going to need to make sure that if we need to strip the new lines, and we're going to do it the slicker way than what I did in the previous video, where we're going to just take the return value from the read line and we're going to apply the strip to it. And a lot of the modern programming languages allow you to do this. It's kind of, we're skipping a little bit of a step, and it's slicker, and you'll see it a lot. So it's good to have that understanding. Okay, so let's test our mechanics. Let's print each line. Get your memory, print your memory. Okay, so, and it does look like each line printed with a \n inside of it. So let's set the breakpoint here. Okay, when we read a line, you see we've already read the first line and you see the \n in it. So, and is that the first one? 151,868. Let's check our limits here. Let's look at our, we can actually go into our folder. Let's hit stop here and we'll go to our folder view with Explorer. I just hit Explorer here. I went into folder view because we opened the folder and oh, yep, it's 151,868. Okay, let's go back to our pie view. We know that we need to strip it. So what we're going to do is we're going to say dot strip. Now let's make sure that this strips the \n by default and we don't have to put in here \n. I think \n is the default, so let's test that and make sure. Okay, we print the line, boom. Oh, something didn't happen there. Still has the \n in it. Okay. Oh, strip works with white spaces by default. Excuse me, I was wrong. It's a good thing I checked, because guess who's your worst enemy? Yourself. Okay. Nope, still not working. All right. I'm doing something wrong. I wonder what it is. You know what? It's a good time for a break, and I'm going to go figure that out. I'll see you guys shortly. And, of course, let you know what's wrong. Okay, we are back. Sure enough, I've got some issues here. Well, the first problem, there's two problems, actually. The first problem is I'm printing line here instead of contents. The second problem, I noticed that I'm only getting half the data, and I'm wondering why. And then I remembered, because line is doing the read line for us. This should be doing the read line for us. So we actually don't need this line at all. Because line, this for loop is doing the read line for us. I think. Let's find out. So I was trying to print line when I was doing a read line of contents, and what appeared, I was only getting half the data. So let's see what's going on here. Okay, good, good, good. Still got the \n. So let's do this. Let's say that line is equal to line.strip. And let's be verbose and actually put in the \n. I don't care what it defaults to. The heck with it. Okay, strip. Boom. Boom. Okay, cool. So that does read it all for us. We don't even need the read line statement. Boy, you gotta love Python. Oh, geez, it really makes things nice and fast and easy. Wow, cool. All right, so let's. Are we getting every line separately now without? Oh, look at that, all that data. That matches. Let's go over here to the Explorer. That matches the size of our file. Is our last output 623, 623, 819? Yes. Good. I have my data. I've printed my data. I am ready for the next step. Awesome. So now let's do the next step. Let's print with every line what year it is. So that means that we need to increment year 1950. So let's do this. Year, this will be after we print it. We want to increment year. Year, and let's do it, instead of year is equal to year plus 1, let's be lazy. Let's do it the lazy way. Year plus equals 1. Good. Then we'll print year. We'll concatenate the print with a \t and tab it out. That should be good. Okay. Oh, why doesn't print like year? Probably because it's an int and we can't concatenate an int with a line. Okay, we can't concatenate. Oh, and then we got our plus here that we need. So we need to use the plus on our tab inside the print line. And it looks like print will convert that numerical value year to an alphanumerical value for us. Gotta love Python again. Okay, let's check it out. Oh, no. Oh, it did not. Oh, operand types. Oh, that means that it does not like adding an int to a string with the plus operator, because year is an integer and we're adding it to two strings. Okay, well, we can do this two ways. We can just say, oh, screw you, comma, print, interpret that as a year. That works. Let's see if that works. Oh, yep, it worked just fine. No problems. Okay, or we could do it this way. We can say plus, and we can say, give me the string. First, convert year to a string, then add it all up. Okay, now let's go ahead and do that again. Okay, yeah, that worked. So that's two different ways that you can do it. That's up to you. I like this version because it's kind of old school. Yeah, it is what it is. So we have more of our information. Do we have the year 90 at the end? 1990, yes. Okay, so then what do we actually got to do with this? What do we got to do with this? What kind of processing do we need to do with this assignment? Let's go back here. We need to find the average annual change in population during the time period. You know what? I'm going to leave that guy up to you guys. We can do this a few different ways. We can throw this inside of an array. I don't think we need a special frequency array for this. Possibly. You may need it for another assignment. You would also call it a frequency list. So that's going to change. We're not going to use a frequency array or frequency list. I think, you know what? Let's just get our years in a list. Because remember, we are learning about lists in this chapter. So I want you to use a list. We can use a list that says that we imply that the item 0 in the list is 1950. Or we can use a two-dimensional list where the year, the first element refers to the year, and then the second dimension, or the first dimension refers to the year, and the second dimension refers to the population. But I think let's just throw it into a list first, and let's process the list, and we can make some logic that describes the year with the specific index in the array. Okay. I think I'm ready to begin. So let's go ahead and create a list. Let's call it populations, and let's just create an empty list here. That's how you declare an empty list. And what we're going to do is we're going to begin by just putting in the population data. Now here's the thing. We have to process the population data with mathematics. So we need to actually convert that population data from its string representation into an integral representation. And you know what? I would rather make it a floating point because you're going to actually be doing some averages with it, which implies division. So let's just start with a floating point instead of having to do a conversion later on from an int to a float. So let's start by creating a list of floating point values that represents the population data. And what we can do is we can just use the append populations dot append, and what we're going to append is the year, not the year, the line that we read that's been stripped. But here's the thing, is we need that to convert to a float. Okay, now again, this goes to get your data, print your data. So we don't need this guy too much anymore. We're just using this loop to, and in fact, you know what? We don't really need that year anymore. We're just using this loop to get the data inside the list. So you know what I'm going to do is I'm going to set a breakpoint here, and I just want to look to see inside of populations if it actually added every line. You know what? No, let's look at it happening line by line. Okay, there we read in the data, strip the data, boom. See the quotes around it? That means it's a string. we're going to convert it to a float, and then it is appended. So first what happens is the float conversion happens. Then what is returned from this converting it to a float, so it'll return a number that it converts it, and then that number that it returns is actually appended. So there's several things that happen here, and it's called operand associativity. It's basically your operator precedence and associativity. So your operator precedence and associativity determines that a conversion happens first before a function call. So this precedence happens first, and then the function call to append it to populations happens. So let's see if our populations, and look at there, 0.0. Okay, I'm going to step over, next append. Boom, and look at it. It's putting it in the list exactly in the format that we expect. Okay, so now I'm just going to get rid of this thing, and I'm going to hit play, and it continues and it finishes. What I want to do now is, now that I've processed and read the information, I can do one of two things. I can process while I'm reading in the information, but the best rule of thumb when you're when you're getting data from a source on disk, whether it's a database or a text file, it doesn't matter. You don't want to process while you're getting the data, because often when you are working with data sources, there are other processes that may access that data, and it may be a process that updates the data. So if you're processing and reading the data that is shared with another process, that processing time on the data that your application is doing may interfere with an update from another process. So the rule of thumb is, whenever you're in getting data from a database, anything, you get in, you get the data, and you get out. You do not get the data, process, print. You get in, you get the data, you get out. You close the file. That is the rule of thumb for anything. So you don't ever want to process while you're reading the data. So once we get the data, we are done. We are now ready to process the data. And for that, what we can do is we can do this. We can do a for in range of the length of populations. Let's just remember, we have our data, but let's go ahead and print this data line by line and make sure that we have our each line of data. So we're going to use the list subscript with the numerical value I here. You can do a for number in for x in populations. That works well too. This should work as well. It looks like, oh, I forgot the I for I in range. There we go. So let's get in, let's get the data, and again, let's print the data after we've gotten the data so that we're not interfering with that particular data source. Okay, so it looks like I was able to print the data with my for loop. So now what we're going to do is we have that completed. Now we get into processing. I think we're ready. We've got the data converted in a list. We're using a list like we want to for our chapter assignment, because every time you get a chapter assignment, it's going to introduce you to some new information. I want you to use that new information in your assignments, not information in a chapter ahead. It'll be in that chapter or chapters before. Do try not to go to a website and get some magic that hasn't been presented to you in your book. Your book has all the example code that you need to complete your assignments. So I'm going to be making sure that we're not grabbing code from websites as a habit too much. Even though, here's the key. In the industry, that's what you'll do. But my concern when I'm looking for that type of behavior is that you're just going out and grabbing somebody that did the assignment for you, their code, and you're not learning anything from it. Because the goal here is for me to assess your ability to write the code for your understanding of it. Even though in the industry you would be implementing it, but that's after you've been assessed on your knowledge of the actual technology, programming language in general, or anything through, the course you're taking right now. So do try to keep away from the magic code on the internet as much as possible. All right, we have the ability now to do one of a few things. You should be able to find the year using the max. So how would that work? Well, wouldn't the max function find the maximum value and give you the index of that year? And couldn't you figure out from the index of that year what was the year with the greatest increase in population during the time period? So what is the largest value in our list? You can use the max, and here you can use the min. And what the max and the min will do for you is, I believe it should give you, and let's just play with this. It should give you, let's just look at it. Let's say index equals max of populations. Okay, now let's just look at what index. And you know what? Let's get in the debugger instead of using print as our debugger. That's bad habits. Oh, another bad habit. Forgetting to set your breakpoint. Okay, so here we go. Index. So let's see what we get from index. What does index give us? Oh, duh. Oh my goodness. Are we going to actually have to... Because it looks like I don't do any code down here. So it just stops and we can't look at it. So I would have to do some other code here. So yeah, I'm going to have to print it anyways. Okay. Okay, step over and we'll look in the debugger for it. Index. Okay, so the value 249623 is the value that's the largest value in this list. So couldn't we find the index from that? Now we know we don't get the index using the max. We just get the value, max value in the list. So how would we get the index of the maximum value? Because then we can relate the index to the year. Because we know that from our file, index of 0 that has this value, that's 1950. That's year 1950. Index of 1 that has this value, that's 1951. And so we know that this is 1950, 51, 52, 53, 54. So once we have the index value, we can then determine what is the year based on its index value, because location 0 is 1950. So then what would we use from there in list to find where the index is? And I believe there's actually a function that we can use for that. And I'm going to go and take a break, and when we come back, we're going to work with that. Okay, guys, we're back. All right, so in the interest of discussing a little bit on how to find resources using Google, using key terms, and here's the thing, it's a fact. I always forget how to do something in a specific language. When you work with as many as you do, once you get higher up in your career, you often need to use references very judiciously because they all mingle together. And the reason for that is because they're all the same. So when I get too talkative about other languages and it gets confusing, I apologize right now for that. However, be aware that every language out there, it doesn't matter what it is, they are all the same. They're just the same. And so when somebody starts talking down about another language, don't listen to them, because they don't know what they're talking about. If they're already saying, oh, this language sucks, guess what? They don't know what they're talking about. Every language has a reason for its existence. It's found a niche and a reason for people to use it. JavaScript, because it's an interpreted language, it is able to come back from errors, and we want that for runtime and uptime on websites. Python, it is great, easy to get things done. Scientists love it because it's relatively fast and it's a higher level language. Very little writing lines of code, more production. I can go on and on about the different languages and their niches. One of them is PHP for server-sided programming. Again, the same, but it has a specific niche for a reason, and that's for its ability to handle, because when you're doing back-end web programming, you're essentially writing code that writes code. And so PHP is able to do that with its syntax rules a lot readily for production than other languages. So what I did here is, because I totally forgot how to find the index of a Python list. So I just typed into Google Python find index from value in list. And it brought up this website. And so here we go. And I probably talked about this in the previous video and just totally forgot. We can actually find the index of a specific item in the list by running the index function on the list. So we're going to use the index function on the list to find the index value of the max. So I can do this. I can say, okay, well, what's the index value of the populations list's index of the max value? What is that index? Okay, so let's go ahead and run it. Step over. Okay, index. It's at index 40. So if we go through all these and we count up all the index, that's the last one, isn't it? It looks like they're in order. That should be index 40. Okay, well then what year is it? Well, couldn't you just do plus 1950? What would that do? $19.90. Woo! Oh my goodness. That's so awesome. You know what? Let's take this a step further. Let's say the heck with this line. Let's say the heck with this line. Let's find the max. You know what? Let's say the heck with this line. Let's say the index is equal to populations of the max value of the populations. Wouldn't that work? Because I can just run the max of the populations list to find the index of the max inside of Oh, I got to do populations.index. Oh, I almost messed up. There we go. I think that'll work. And let's get rid of this. We don't even need this for that, do we? Oh, we may need that for doing the average. You guys will need this for the average. And I'm going to leave that to you because I've already covered how to do averages from a file data in a previous video. So we're at a stopping point pretty soon here. Let's see how far we can take this. Couldn't we just get rid of index altogether and just say year? And in fact, for that matter, let's get rid of that. Oh, heck with this. Let's just do this. Let's say print the max, the year with the highest population. And you guys are going to want to add some more to this. And we'll say plus, let's put a space in here. The year with the highest population is, and we'll do population. Oh, you know what? We're concatenating with a string. So this returns a numerical value, but this just returns the index of the highest population. Let's do a plus 1950 here. And let's take that whole value and convert it to a string. Oh, that messes up. All right, so why are we messing up here? Oh, we're missing a parenthesis. So let's say open, close, open, close. Oh, open, close. Okay. No, two closes. Okay, so we got open, close, open, close, open, close, open, close. The year with the highest population is 1990. Whoop whoop! Okay, we didn't need a frequency array. All right, guys, if I was getting down on a frequency array earlier in the video, we didn't need it. One of the assignments does need one, but I'll do probably something if I end up assigning that. I'm going to turn the rest of this over to you guys to finish up as indicated in the assignment. And we are at a stopping point for this video demonstration in our bit of fun for the week. All right, guys, take care. Bye-bye.